Okay, gonna look at the squaring process in more detail, in more depth. And I think this is an important conversation to have for those of you who are going up the ladder in this discipline. You want to get to calculus and you want to understand it, then these are some things you want to start thinking about now, not then. Okay, and I've got a lot of years of experience for making that comment. All right, so let's just look at the squaring process. User-friendly numbers here. -3 times -3 gets us an area of 9. I've used a bar graph here to show those 9 units. -2 times -2 is 4. Okay, so we've gone down 5 units from 9 to 4, and our dimension went up 1. Right, so we're going down at 5 to 1 right here. 5 to 1. Okay. And -1 to times -1 is 1. Now we're going to go down from 4 to 1. We're going down 3 units to 1. And then -1 to 1 to 0, we're going down 1 unit. And then we repeat the process, but we start going up by 1, up by 3, up by 5. You know, that's kind of average rates of change between one X value and one Y value to another X value and another Y value that we can hopefully see easily. Okay, so those square areas are changing. Right? There are a lot of numbers between 0 and 1 and 1 and 2 and 2 and 3. And we could have crunched those numbers just as easily. All right, and we're going to here. All right, we're going to look at the patterns that emerge. All right, the rates of change that emerge when we start taking a microscope to this process. Right now, we got kind of a macro view. We're standing back. Right now, we're going to start to go from -3.001 to -3, and we're going to square those numbers. And I didn't use a calculator for any of these calculations because I've seen the pattern over the years. Okay, and if you square -3.001, you get 9.006001. 3 decimals become 6 decimals. And if you look at the change, you're dividing 0.006 divided by 0.001. This is 10, 100. This is 1,000 times smaller than, 0.000001. It's got 3 decimal places pushed out to the right, and each decimal place is a factor of 10. It's small. We can push that critter way out, and we're gonna later in the video. All right, so really, accuracy here is 0.006 divided by 0.001. It looks like it's going down at this instant about 6 to 1. I'm going to erase these average rates of change from one integer to the next. I'm erasing those now, and I'm kind of zeroing in on what's happening at that instant. -2, I kept it to 3 decimal places. -2 squared is 4. -2.001 turns out to be 4.00601. There's 0.006. Oh, I made a boo-boo here. It should be 0.004. Okay, put this up too quickly before. I'll get 4.04001, and that's going to be a change of 0.004 divided by 0.001. But we're coming down now, right? Coming down, so we're subtracting. So that's coming down at 4 to 1 at that instant. All right, let's get another decimal in here. Let's put another decimal place. -1.001 squared. Yeah, I'll highlight that too. Gets us 0.002 divided by 0.0001. We're coming down, remember? So that's a 2 to 1. Woo, I'm starting to see a pattern, are you? At -3, it's going down at 6 to 1. At -2, it's going down at 4 to 1. At -1, it's going down at 2 to 1. And at 0, it's flat. It's flat. There's no change. Look at how far out I gotta go. If I did 5 decimal places, it takes 10 decimal places before that digit shows up. There's not really changing there. Okay, we're going to draw the change in a minute. We're going to look at this from a geometric standpoint. But, now we're going up, right? From 1 to 1.001, we're going up. And at 1, this, I made another mistake here. That should be a 2. All right, and so if I look at that, 0.001 divided into that goes twice. So I'm going up at 2 to 1 here. I'm going to be going up at 4 to 1. I'm going to be going up at 6 to 1. And that appears to be 2 times whatever X value I'm at. Doubling it tells me the rate at which I'm changing in the squaring process. So let's look at really pushing one out here, 2.0, 4.0, 6.0. You know, I could express the decimal that way. I think NASA, you know, works in space with 8 decimal place accuracy. I think we can ignore this. All right, so if we change by 1, 2, 3, 4, 5, 6 decimal places, 1, 2, 3, 4, 5, 6 decimal places, and we divide that, sure, we get a ratio of 6 to 1, and that's how this is changing at an instant. So let's draw some lines here to represent area. And let's actually talk about that being all colored in. When I draw another layer across on those side lengths, I've just increased the area by a little bit, just by a little bit. All right, let's actually do this one. Let's say that I only go out 0.01. So you can see this, I've got to draw a little rectangle here. And I got to draw one there as well. And 0.01 is getting really, the accumulation of area here is coming from 0.01 to this side, right? It's this side length. So that's 3. So that gets me 0.03. And the same thing's happening over here. 0.01 times 0.03. And then we have 0.01 times 0.01. And that's where we're getting those lengthy decimals at the end, kind of like the tail end of this calculation. Right? And so there's the doubling process. The doubling of what? The side length. Okay, doubling of the side length. Okay, so that's what gives its shape. That's what gives the quadratic its shape. Right? And at each instant, you know, we can talk about how we're changing to get a little better feel for the continuity of that function. All right. Okay. I just planted a seed. All right. And that seed is what's called a derivative in calculus, a layering process. And if I were to do an addition of all these layers, and if I kept adding them and adding them and adding them, in other words, if I went to 1.002 and squared it, which I don't know the answer to right off the bat, right? That would be another layer, so on and so forth. And if I kept doing that, 1.003 and kept doing that and added up all these changes, well, I would get the difference between 9 units of area and 4. That's what you're going to be studying in the future. All right, and so I want to plant that seed now. I definitely want to plant that seed now. And you can't study this unless we get all of those foundational mechanics done in this Algebra 2 year. All the factoring we got to learn how to do, how to solve equations using factoring, which is really writing sums and differences as products. So I'm not even sure I'm going to use the word factor. All right, because if you ask students what factoring means, sometimes you don't get much of an answer. All right, so what's another way of writing? What can I do? 2x plus 3x. Well, we say it's 5x. Why? Because x is common to 2 and 3, right? That's addition, that's a sum, that's a product. And earlier in some of the earlier videos, linear videos, we've talked about the importance of products. The importance of products equaling 0, right? And we're going to see that. We're going to see that, and I don't think it hurts to put this in another video, but we're going to be studying ax squared plus bx plus c. And I can write this as a product. I can write that as a times ax plus b plus c. And if I want this product to equal 0, I get two numbers. I get 0 and I get minus b over a. And if I add those up and divide by 2, I get a very important term, minus b over 2a. Now, and in this instance, these numbers get me c. 0 gets me c, and minus b over a gets me c. And if we know that we have a cup-shaped graph, then where's the most important number? The one in between 0 and minus b over a, which is minus b over 2a. There's lots of reasons for why that's important. That's just one of them. Right? That's just a mechanical reason. We've got geometric reasons we're going to talk about too. Okay, so the conversation's got to start somewhere. And in math, you just have to be patient and then continue to have the conversations until the lights go on as to, oh, I understand what we're talking about now. Okay, and that doesn't happen instantaneously like these rates, instantaneous rates. No, you got to be patient and we got to get to work. All right. Some things to think about.